Well, we are back. This time we are talking about pathology, and we're going to have an overview of the normal immune response, hypersensitivity, and autoimmune disorders. We're going to talk a little bit about amyloidosis. And if you're just joining me for the first time, I'm not a doctor, I'm a medical student. I make these videos because talking about the lectures, talking about what I'm reading about really helps me understand things before I take tests. So it works really well for me. I have more than 500 videos at the moment. But if you really want to learn about pathology, go to medicalschoolpathology.com and listen to the lectures of Dr. Minarsik. Also look at shotgun histology on YouTube and you can see some amazing things. So that's basically where I first learned about pathology, and now I'm in med school and I'm just taking these classes. So anyway, so let's get going. So let's continue, and we're going to start with major histocompatibility complex, and we're not going to talk about innate and adaptive immunity. We've gone over that, so you should know the difference between the two. But let's start by asking a question regarding major histocompatibility complex. It is a genetic locus on which chromosome which codes for cell surface compatibility. It is chromosome 6, and it is also known as what? Also known as HLA, or human leukocyte antigens in humans, and H2 in mice. So what is the job of HLA, or major histocompatibility complex? Its major job is to make sure all self-cell antigens are recognized and tolerated. We'll talk about this system later, but remember that the general rule of here is that in the immune system, all unrecognized antigens will not be tolerated, and then we'll go into what happens in that situation. Okay, well, it looks like we're going to have a short introduction of innate and adaptive immunity. So let's talk about some of the players. Of course, we're going to talk about barriers in innate immunity, and in a perfect world, our barriers would be perfect and nothing would get in, but this is not true. So we have cells that are involved in innate immunity, and these are the lymphocytes, macrophages, plasma cells, and natural killer cells. Then we have signaling cells, signaling molecules such as the cytokines, chemokines, and we have plasma proteins, complement, coagulation factors, and then we have, of course, those TLRs, those toll-like receptors that recognize the PAMPs. And we're not going to confuse those other tests, are we? And in adaptive immunity, we have the cellular and humoral type. In cellular, we have the direct cellular reactions to antigens, and of course in humoral we have the antibodies which are produced by B cells. We've talked about this before. So as a general summary, talking about humoral and cellular immunity, we know that in humoral immunity there is an extracellular microbe, whereas in cellular immunity we're talking about an intracellular microbe, for example a virus. But in extracellular humoral immunity we have an antigen, we have B cells that secrete antibodies, and we have neutralization, lysis, through complement phagocytosis. We have PMNs, we have macrophages, and using like lysosomes, enzymes, we're going to destroy this phagocytosed microbes. The same thing is happening in cellular immunity, except that we have an intracellular microbe, for example a virus, and then we have an antigen presenting cell, or an APC, that presents that antigen to the helper T cell, which then releases cytokines, and we have proliferation into the effector cells. Then we have macrophages, cytotoxic T cells that eventually lyse the infected cell. So the final result is the same, the destruction of phagocytosed microbes, but we should understand that in humoral immunity it is extracellular microbes. We're looking at, for example, bacteria, whereas in cellular immunity we're looking at intracellular microbes, e.g. viruses. Anyway, so just don't forget the cells of the immune system. We've talked about lymphocytes, T cells, the B cells, the plasma cells, which are the modified B cells, the macrophages, the APCs. Remember the different types of APCs. Remember the dendritic cells and the natural killer cells. Don't talk about those in detail. We talked about the dendritic cells, and remember that when you look at them, they have dendrites projecting out, and they're looking and feeling out for these antigens. And where would they be found? Where would you find dendritic cells? Well, you'd find them in the skin, the inner lining of the nose, the stomach, the GI, and they are contacting the external environment. And if you can remember how they look, then it will be easy to remember how they present the antigen, how they take them into their bodies and then present them to the T cells. Anyway, let's talk now about the natural killer cells. So here's the question here: what do the NK cells release? What is it that they release to cause death? Remember, the cells kill by releasing small cytoplasmic granules of proteins called perforin and granzymes that cause the target cell to die by apoptosis. So the perforin will actually form pores, which allow the influx of what? Can you remember? The influx of calcium. So this then results in death by apoptosis.